So let's just talk about binary search in Python. So previously we have talked about this linear search. So in linear search, we check each element in the list one by one sequentially to find the target element. But the problem with the linear search is that it works well for the small list, but it becomes inefficient for large list. So in case of a larger list, this will take a lot of time to check for the target element. Now to overcome this problem, we can use the binary search. So in case of this binary search, we divide the search space into two halves. Because we are dividing in two halves, that's why it is called the binary search. So suppose we have one list of items looking for target item in that list. So in case of binary search, we use the lower bound and the upper bound. So let's now take a look at the algorithm of this. So first of all, we divide this list into two halves. So we calculate the mid, which is lower bound plus upper bound by 2, and then we compare with the mid value. So then we compare the list mid with this target value t. So we compare with the t. Now there can be three outcomes. First of all, they can be equal. So in that case, we found that element right in the middle. So that means the element is found. So we're just gonna basically return the index of that item. So in the second scenario, the mid element may be smaller than the target. In that case, so because the mid item is smaller than the target, that means the target will exist between middle and the upper bound. So the target will be right here, somewhere right here. So in that case, so we're gonna shift this lower to this mid position. So we're gonna move the lower to mid position plus 1. So we're gonna shift our lower bound right here, mid plus 1. And there can be third situations where the mid value can be larger than the target. That means, so it will lie between the lower bound and the mid. So in that case, we have to move the upper bound to the mid minus 1. So here we have to move the upper bound to mid minus 1. So now we're gonna repeat this process until the lower bound becomes larger than the upper bound. So when this happens, that means the element is not found in that list. So in that case, we're gonna say that the element is not in that list. And that is our algorithm for the binary search. Now the binary search has the best case complexity of O1, and that happens whenever we found that target element right in the middle on the first try. And it has the worst case complexity of O log n, and it has the average case complexity of O log n. So the binary search is also going to take the list of items and the target. Now inside that, we're not going to check for all the items. Instead, we're gonna divide that list. So here we're gonna use the lower bound, upper bound value, which will be 0. Now the condition is, so the loop will continue as long as the lower bound is less than or equal to the upper bound. And then we have to calculate the mid position. So the mid will be lower plus upper by 2. Now we're gonna have the condition. So the first condition, we're gonna check if they are equal or not. So if the value at the mid position is equal to the target, that means we found the target. So we're gonna simply return the index. So this is when we found the target. Else if the array mid is lesser than the target, so in that case we're gonna move the lower bound. So the new lower bound will be mid plus 1. So here we're gonna shift lower bound. Else, otherwise we're gonna shift the upper bound. So the upper bound will be shifted to mid minus 1. So here we're gonna shift the upper bound. So this loop will continue. Whenever the lower bound becomes larger than the upper bound, then the condition will be false. In that case, that means the value is not in the list. So in that case, we're going to return -1, which will indicate that the element not found. And now here we're going to call the method binary search. Now this will return the result. So if the result is not -1, that means the element is found in the array. So we're going to print the element and the index of the position. Else we're gonna print the element not found. So let's now run this. So here it says element not found. Oh, here is a problem. The lower bound has to be 0. So the lower bound will be 0 and the upper bound will be the length of the array minus 1. So here the lower bound is 0 and the upper bound is the length minus 1 because the indexing starts from 0. So that is the problem. So let's run this again. So now you can see, so found element 5 at index 2 because here is our element in the list. So let's now try with the element 10 which is not in the list. So now we are getting element not found. So that means our binary search is working properly, but this time it is much more efficient than the sequential search. So one of the important conditions to apply binary search is that the array has to be sorted, and then only we can apply binary search. And because the binary search is really efficient than the sequential search, so this search can be applied to large list of items. So hope you understand about binary search in Python. See you in the next one. Take care.